Hello everyone and welcome back to the channel. Today we'll be doing a question on application of derivative, exercise 6.3. These are the word problems based on maximum and minimum. We'll be taking up question number 23. So the question says, prove that the volume of the largest cone, that means the volume should be maximum, which can be inscribed in a sphere. So we have a cone in a sphere. So let's take a sphere and inscribe a cone in it. Now we want such a cone whose volume is maximum and the radius of the sphere is given r. So if we take the cone as ABC, drop a perpendicular, that is the height and the radius here. Okay, will be, suppose if the center is here, this is the radius and this is also the radius. So actually the height of the cone which we have taken here is h plus r. So capital H we will write. And let's call this point as E. Now one thing we see from here, okay, first let's write down the volume of the cone which we need to maximize. So volume of the cone is 1 by 3 pi r square capital H. R is the radius of the cone and the height of the cone is, because the radius is also included here, we have taken it as h plus r. So here we have two variables. Capital R is constant because the cone is, the sphere is already given to us and its radius is fixed. What is variable here is small r and small h. Now I want to convert this to one variable, so it's easier to solve. So one thing we see here is, this is a right angled triangle. Triangle BDE is right angled. So we can use Pythagoras theorem and we have r square is h square plus r square. From where we have small r square is capital R square minus h square. Let's put it here. Capital R square minus h square. So this is a function in h. In order to find maximum or minimum, we need to find f dash h, we need to find the critical point and then go for f double dash h. So we'll do stepwise. Okay. So in order to find f dash h, you can follow different methods, but I have, you can take u into v product rule for derivative. I have simplified this. Now I will find f dash h. Because r is constant, it is r square into derivative of h, which is 1. This is 0. So we have 1 by 3 pi. Now this is a quadratic in h. We need to factorize this in order to find the critical point. So let's factorize. So the factors are r minus 3h and r plus h. So equating both of them to 0, in order to find the critical point, we have h as minus r, which is not possible, and h as r by 3. So we'll take h as r by 3 as the critical point. But we are looking for largest cone, so we also have to find f double dash h. We should actually be numbering the equations to make our work easier. Okay, this is f dash h, which we have factorized further, so we will differentiate this one. You can differentiate any, but this one will be the easiest. So I'm going with the third equation. Differentiate with respect to h. So r square is constant. 2r, derivative of h is 1 and h square is 2h. Now we know that the critical point is r by 3, so substitute h as r by 3. Minus 4r, it's negative. That means the function fh or the volume of the cone is maximum. So we have volume is largest or maximum. So we have finished the first part. proving that the volume of the cone is largest. Now we also have to prove that the volume of the cone is 8 by 27 times the volume of the sphere. So this critical point we have to substitute in the volume of the cone, which we have written here in terms of h. So we'll substitute the value of h in equation 1. So on substitution, we have h being r by 3, it is r square by 9, and over here r by 3. Let's simplify this. And as we know, we want 8 by 27 of the volume. Let's put 8 by 27 ahead, 8 and 27. What remains is 1 by 3 pi r square into 4r. So that is 8 by 27, 4 by 3 pi r cube. That is the volume of the cone. So we have 8 by 27 times the volume of the cone. So such a sphere which has maximum volume will be 8 by 27 times the volume of the sphere. That's what we were supposed to prove, and we are done with that. So if you are interested in questions like this, if you think someone will be benefited, then please do share the link. Also do subscribe to the channel, and see you soon. Thank you.